Welcome to Learners Academy, and today is the second lecture on distinguish between, and these are the quick revision series where I'll be preparing for final exam and I'll be covering all the distinguish from the chapter 3rd and 4th, that is chemical reactions and equation and effects of electric current. So stay focused throughout the session. Let's start now. Let's understand the difference between physical change and chemical change. The physical change is a change in which only physical state of a substance is changed. No new substance is formed. This change is temporary, and during this change, the composition of the substance does not change. On the other hand, chemical change is a change in which substance or substances, they are converted into new substance or substances possessing properties altogether different from the original one. They are called chemical changes. During this chemical change, the original substance cannot be recovered, mind it, cannot be recovered by any simple means. This change is permanent. Now let us see the point-wise difference between physical change and chemical change. Physical change is a temporary change. On the other hand, chemical change is a permanent change. The state of substance changes, but chemical properties remains same in case of physical change. On the other hand, chemical change, in this, the state of the substance may or may not change, but the chemical composition of the substance changes. All right. Third point, in physical change, no new substance is formed. In case of chemical change, new substances are formed. Physical change is often reversible, all right, and chemical change, it is often reversible, all right. It is often irreversible. Now, steam formation and steam condensation, these are the examples of physical change. And for chemical change, we can see ripening of fruits, spoiling of milk. So we cannot get raw fruit after the fruit ripens, and we cannot have the proper milk after it gets spoiled. All right, so they are irreversible. We'll move on to the next slide now. Let us understand the difference between a combination reaction and a decomposition reaction. Combination means when two substances, they combine together. For example, A combines with B and a new product AB is formed. On the other hand, when a compound breaks down and it decomposes into two products, A plus B, that becomes a decomposition reaction. This is the basic rule. All right, you will not write this for the exam. This is for your understanding. Now, in a combination reaction, two or more reactants. So here, what were the two reactants? A and B. Take part in a chemical reaction. In case of a decomposition reaction, there is only one reactant. There is only one reactant here. All right. Now, in a combination reaction, only one product is formed. You can see here, there is only one product formed here, AB. While in case of a decomposition reaction, what happens? Two or more products are formed. You can see there are two or more products formed here. All right, B and A. So this is the second point. Now I'm going to give an example of a combination reaction. For example, I'll change the color of the pen and I'll write it with the yellow. Carbon, which is solid, when it reacts with oxygen, which is a gas, it gives rise to carbon dioxide. Now this is a combination reaction. You can see there are two reactants. How many reactants are there? There are two reactants and there is one product. On the other hand, example of a decomposition reaction. So for example, calcium carbonate is the compound and it is solid. It decomposes. It breaks down in the presence of heat into calcium oxide, which is a solid, and carbon dioxide, which is a gas. So whenever we use this type of arrow, that means it is a gas which will escape in the reaction. So you can see there is only one, there is only one reactant here, and there are two products. Alright, this is what we learned here, that we have two or more products and there is only one reactant. So that was all about the difference between a combination reaction and a decomposition reaction, and it is very, very important that you write the equation. Please write equation for the exam. It's really important. All right, please write equation, that carries marks. Let us understand the difference between oxidation and reduction. Oxidation means substance gains oxygen. All right, please remember, this is the way you will learn this. Oxygen, it gains oxygen. All right, and or it loses hydrogen or it loses electrons. It gains oxygen. Oxidation means. On the other hand, reduction means it gains hydrogen. All right, it gains hydrogen. That's important. This is how I learned. And or it loses oxygen or gains electron. This is how you will remember what is an oxidation and what is a reduction. Now let's have a quick review of the point-wise differences between oxidation and reduction. The chemical reaction in which reactant gain oxygen or lose hydrogen is called oxidation. All right, this is very important. On the other hand, the chemical reaction in which a reactant gain hydrogen or lose oxygen is called a reduction. It also gains electron. All right, it also gains electron. All right, here it will lose electron. In this case, it will lose electron. It loses electron. Now, second point, a reducing agent undergoes a oxidation. On the other hand, now before that, I'll give you an example of an oxidation reaction. For example, we take copper, which is solid. It oxidizes in the presence of oxygen, and heat is also required. So what do we get? We get copper oxide. We get copper oxide, which is solid. So this reaction is called a oxidation reaction. Please write equations for your exam. It's very important. It carries marks. All right, now on the other hand, in case of reduction, an oxidizing agent, in case of reaction, oxidizing agent undergoes reduction. Here it was reducing agent, here it is oxidizing, opposite. All right, please try to remember this. In case of reduction, an oxidizing agent undergoes reaction, and here you can see a reducing agent. Now the example. So let me recall and give you an example of a reduction reaction. For example, we'll take copper, which is solid. It will add with hydrogen, which is gas, and we'll get methane, CH4, which is also a gas. This is a reduction reaction. All right, it's very, very important to write equation. I keep on telling, write all equations. It's very important. Now let's move on to the next difference. What is the difference between exothermic and endothermic reaction? See, by the name itself means that it is related to heat. It is related to heat. Thermal means heat. So it has something to do with heat. Exo means it releases heat. It releases heat. Okay. And endo means it absorbs heat. It absorbs heat. And thermal means heat. So this reaction has something to do with the heat, either while this reaction takes place, some heat is released or it absorbs heat. All right. Now the first point is the reaction in which heat is evolved. All right. The main point is in which the heat is evolved. Please remember, is an exothermic reaction, and here if the heat is absorbed, that is called endothermic reaction. The evolution of heat leads to a rise in the temperature of the solution. All right. The absorption of heat, on the other hand, leads to fall in the temperature. All right. This is the main key point. Now, example of exothermic reaction will be, for example, what I can give you, calcium oxide, which is a solid. So you have to write everything. Please don't skip this. It reacts with water, and when calcium oxide reacts with water, we get calcium hydroxide, and which is aqueous, plus heat is produced. All right. When this reaction takes place, heat is produced. So that is why this is a exothermic reaction. Now, example of an endothermic reaction is, for example, all right, let me give you an example of endothermic reaction. Calcium carbonate. For example, we take calcium carbonate, all right, which is a solid. When we heat this, heat is required to get calcium oxide, which is solid, plus carbon dioxide, and carbon dioxide is a gas. So heat is absorbed in this reaction. For this decomposition reaction, heat is required. All right. So that was the difference between an exothermic reaction and an endothermic reaction. Now we come to chapter number 4, effects of electric current, and the first difference that I come across here is a difference between alternate current and direct current. So alternate current basically means the alternate current varies in magnitude continuously. This is very important. All right. On the other hand, it remains, the direct current remains same, it does not change. All right. Now the direction of the alternate currents get reversed periodically. On the other hand, it flows in one direction. Direct current flows in one direction. Direction remains the same, it does not change. All right. Now alternate current is used in household electrical appliances such as electric iron, fridge or fan or any other instrument. On the other hand, direct current, this type of current is used in the batteries, it is used in the torches. It cannot be used for large scale production of electricity. It's very important. All right. Now alternate current, in case the frequency of alternate current is 50 Hertz in India, its cycle changes after every 50 seconds. All right. This is very, very important point. On the other hand, frequency of the DC is 0. Okay. The last point, it is produced by the AC generator and it is produced by the DC generator. So that was all about the difference between alternate current and direct current. Now let us understand the difference between electric motor and electric generator. In case of electric motor, we see that electrical energy is getting converted into mechanical energy. On the other hand, in case of electric generator, mechanical energy is getting converted into electrical energy. This is the key difference between electric motor and electric generator. Now let us see the point-wise difference between electric motor and electric generator. The first point of electric motor is that in this case, the current carrying coil is set in rotation due to the magnetic field. In case of electric generator, a potential difference and hence current is produced when the coil is set into rotation in the magnetic field by an external agent. So there is a use of external agent. Now next point is split rings are used in case of electric motor. In case of electric generator, split rings are not used. They are not used. Next point is battery is used in electric motor to pass a current through the, so battery is used. All right, battery is used. In case of electric generator, battery is not used in an electric generator. In this, electric energy is converted into mechanical energy. This is the point which I have already discussed in the beginning. All right, see here. And in case of electric generator, mechanical energy is converted into electric energy, which I have already discussed. Now, the electric motor is based on the principle that a current carrying conductor placed in a magnetic field experiences force. Okay, the principle is not written here. So I will write that this is the principle on which it is based is that a current carrying conductor placed in a magnetic field experiences force. So this is the principle on which electric motor is based. Now the principle on which electric generator is based, so I'm going to write that also. Now it works on the principle of electromagnetic induction. All right, it works on the principle of electromagnetic induction. All right, so that was the difference between electric motor and electric generator. Now let's move to the difference between AC generator and DC generator. In the previous slide we have differentiated between electric generator and electric motor. In case of electric generator, you remember what did we do? Electric generator, we know that mechanical energy is converted into electric energy. All right, so now AC electric generator can be of two types, AC generator or DC generator. All right, so now we are going to understand the difference between AC generator and DC generator. In both these cases, mechanical energy will be converted into electrical energy. Here also mechanical energy will be converted into electrical energy. But what is the point of difference? So we are going to do it point wise. In an AC generator, the rings are not split. All right. In case of DC generator, split rings are used. All right. In case of AC generator, the direction of the current produced reverses after equal interval of time. Please, important point. Here, the current produced in case of DC generator flows in the same direction all the time. Here, in case of AC generator, it is used to produce alternate current. It is used to produce alternate current. In case of a DC generator, it is used to produce direct current. All right. So that was all about today's session. Last year I taught my son in the similar manner because sometimes I used to record my audio files for him so that when he's tired and he doesn't want to open his book, he would just listen to my voice and revise. So wanted to share the same with you all because the more you share, the more knowledge is that you gain. You also share these videos widely among your friends and keep learning and subscribe to the channel. Thank you very much. Bye bye.